So the flip side of having your function definitions come first is having a function prototype come first. So if you look up above, and I literally mean this like concrete sequentially, is your prototypes come first. So you'll notice here on line number 10. So this program, before I continue any further, I should mention, this program is exactly the same as our previous example. The only difference is we have moved from having our function definitions that came first to having our function prototypes this time around that come first. So here, main starts on line 10 as opposed to line 30 something like it did in our previous example. And here we have our function prototypes up on top. Now, a prototype allows you to add things that you know you're going to need later on in one very tight, very compact space so that as the next developer in the chain or other developers as the next developers in the chain come through, we can look at just a very rapid fire listing of functions that your program is going to undertake and then worry about them later. This is nice when you're working with a big piece of code that you have a lot of functionality that you're going to bake in and you're putting a down payment on something. Let's say I have addition, subtraction, multiplication, division, and simple interest for whatever reason. I know that simple interest requires a bunch of extra stuff, but I also know that right off the top of my head, I can't get that right. So I can build a function prototype that says, let's build this out later. And you can build it out later, but you can make a call to it wherever you're supposed to, and it can simply return to you like you have to build this out later on. It's a way of giving you flexibility as a developer to power through certain aspects of your code and to flounder a little bit, frankly, on building other parts of it out later on. It's also really compact and concise as a next developer in the chain to go like, okay, this is what we're doing here. So with the function prototypes, you'll notice we've got a little bit of a difference between this example and our previous example. Here, I do still have my return types. So int for addition, subtraction, and multiplication. So again, this is going to have a return statement in the function definition because I have int here up front. Double, so here on line number 8. So division is going to have a return statement of division or a return statement that includes the result of division that is in floating point, or in this case, double format, because there I have double. But you'll notice I just have int, comma, int. I have double, comma, double. I don't have variable names even in here. All I'm suggesting to the runtime environment is these are the things I'm going to need. Set that stuff aside over here. And later on, during runtime, when I have to call to it, you can, go run that piece of code and be assured that we have enough storage for it. We have enough, system-wide resources for it. But I don't need to have those all, sorted out here in a concrete sequential way at compile and at runtime. So we have main. That's our next component here. Main runs its 20 lines of code, 1 and 2. I have my double for 3. I've got my calls here on lines 21, 2, and 3, and 25. I have my calls out to my functions, but I'm not really calling to a function prototype here. I am really calling during runtime. I'm going to call down here to my function definitions, the real function. And here in my function definitions, you'll notice these are exactly the same the way that they were in our previous example, when essentially lines 32 through 51 were just cut and pasted up here. So why do we want to do this? If the result is exactly the same, I'm just going to go ahead and run this. I believe I did 5 and 10. And you can see that the results are all the same as they were in our previous example. Why do I want to add 4 extra lines of code and kind of change the structure herein? Because flexibility is always better. If everything had to be with a function prototype first, that's going to, excuse me, that's going to reduce the amount of opportunity that you have later to just kind of fuzzily define a prototype really quickly. If we don't know what we're going to do with simple interest, I can make here a void simple, and boom, there's my function prototype. I'm just going to copy this. I'm going to come down here to the bottom of my code. I'm going to paste it. There we go. And now simple interest is a void. There's nothing in there. I can put out a simple cout statement. There we go. That's the end of my void for simple interest. There is no return. It simply does its work and terminates. So here inside of main, after my cout for 3, I'm going to cout the result of a call to simple interest. Actually, before I run this, I don't need the cout here because I'm couting a cout statement. So that's redundant. I have my cout here in my call to simple interest. So all I have to do here on line 30 is a call to simple interest. See what happens when you slap programs together quick? Sometimes you forget and make mistakes. So we're going to go ahead and run this. I'm going to have 2 integers, 5 and 10. And, well, sloppy copy right there. But this is from SI, simple interest. It's a call here to my void function. Now, as I go through later on, I know I'm going to need to come back to simple interest. I could always say something like, make sure you complete this in my comments and make sure that I come back and do something about it. But that gives me the flexibility here to go through to complete more of my program and figure it out later on. More flexibility is better here.